this is the second operation that we would be learning about today, that is intersection of sets. Now, when I talk about intersection of sets, or intersection of two sets, it only contains the elements that are common to both my sets. Okay, let us take an example and understand. Suppose my set A contains element 1, 2, 3, 4, 5, and my set B contains element 2, 4, and 6. Now, when I talk about intersection, as I said earlier, intersection is the set of all elements that are common to both the sets. Now, this is represented by an inverted U, okay? And I will read it as A intersection B. Now, what are the elements that are common to both the sets? One is present in A but not in B. Moving on to 2, 2 is present in both the set, it is common. So, now I have my element 2. 3 is not present in B. 4 is present in both A and B. Next, I have 5 in A but not in B, and 6 in B but not in A. So, this is how I write my A intersection B. I hope this is clear. Now, and this A intersection B is symbolically written in set builder form as the set of all x such that x belongs to A and x belongs to B. That means this element has to be contained in both my sets. I hope that is clear. Now, let us have a look at another type of sets. Now, suppose I have two sets. Let me represent it again. 1, 2, 3 is my set A, and my set B contains 4, 5, 6. Now, let me find out the intersection of these two sets. Now, A intersection B, I will have to write the elements that are common to both the sets. 1, 2, 3. I do not find 1, 2, 3 in B. B contains 4, 5, and 6, which I do not find in A. So there is no element that is common in both A and B. So my A intersection will be my null set, or it would be 5. Now such sets whose A intersection B is equals to 5 will be called as disjoint sets. What am I calling these as? I am calling these as disjoint sets. Now let us see how this is represented. Both A intersection B is represented pictorially. Now when I am representing A intersection B, as usual, I will have to draw my universal set, and this would be represented by letter U. Next, I will have to draw my two sets A and B. This is my set A and this is my set B. Now, what is A intersection B? A intersection B is the part that is common to both the set, and that is this middle region that you see. So this is how I represent my A intersection B. I hope that is clear. Now, when I am representing my disjoint sets, how will I represent my disjoint sets? There are two sets which do not have any elements that are common to both the sets. So I will represent it as this is my set A, this is my set B. So there are no elements that are common in both the sets. Now let us look at some of the properties of operation of intersection. Okay, now properties of operation of intersection. Now, as we have discussed the first property of union, that was commutative, the same law will also be applicable here in the case of intersection. Now, what was the commutative law? We know that A intersection B is equals to B intersection A. Whichever way I do it, I just have to choose the common elements between A and B. Now, moving on to my second law, that is associative law. that contains three sets. Okay, and I would be finding out the intersection between A and B of intersection C will be equals to A intersection of B intersection C. Now, whichever way I do, I will have to choose the common elements in all the three sets A, B, and C. So that will definitely be the same. Now, the third law that we would be talking about is called as my law of phi or law of U. Now, we'll be discussing two laws in this. The first is phi intersection A. Now, what is that element that is common in phi and A when we're doing the intersection? Obviously, it is phi. Now, again, universal intersection A. Now, what is common between my universal set and my set A? Obviously, my set A is common in my universal set and my set A. Now, this will be called as law of phi, that is my null set, and U. Now, moving on to my idempotent law, which we have also discussed in the case of union. If you all recall, what is idempotent law? We did A union A in the case of union, but here would be doing A intersection A. So what is the element that is common in A itself? Obviously A. So all the elements that are present in A would be A intersection A. Now, one last property is my distributive law, which was not there when we were discussing the union. Now, it states that A intersection B union C will be equal to A intersection B union A intersection C. Now, this means that the intersection distributes over my union. I hope this is clear. We have also discussed similar distributive property when we were doing, I suppose that was related to multiplication and addition, and multiplication over subtraction when we are doing it for integers. Now, let us look at few of the Venn diagrams and understand as to how do we write the relation between them. Now, here are the some of the Venn diagrams that have been taken from the textbook. Now, let us have a look at this Venn diagram. I have a universal set and I have sets A, B, and C. Now, what do we see? We see that the set B and the set C are completely shaded. That means it is the union of set B and C. So, I will write it as B union C. Now, what do we see? The common part of A and B is shaded. That means this is intersection of my sets A and B. Now, let us go for this. Now, which common part is shaded here? The common part between A and C is shaded. So that means this would be my A intersection C. Now, if you pay attention in this last Venn diagram, this is the common part between A and C. So this would be A intersection C. But I have another common part that is between A and B. So now, can I write it as A intersection C union A intersection B? Yes, it means that this is a union of A and C, union of intersection of A intersection C and A intersection B. Little confusing, but if you look at it carefully, you will understand. Now, let us see how do we calculate difference of sets. Now, we will be discussing another concept, that is difference of sets. Now, what do we mean by difference? That means I am subtracting one set from another. Yes, absolutely right. Now, suppose if I write a set A minus set B, what do we understand? I am removing B from A in this case. That means the elements which only belong to A but not the elements that belong to B. So what is A minus B? Yes, A minus B will contain the elements which belong to A, but it will not contain the elements that belong to B. Let us understand this through an example. We will have a better clarity. Now, suppose my set A contains elements 1, 2, 3, 4, 5, and 6, and my set B contains elements 2, 4, and 6. Now, when I find the difference of A and B, that means I'm removing my B from A. What do I get? This is my A. Now let's remove B. B contains 2, so 2 will be removed from this. It contains 4. If I have 4 in A, it would be removed. It contains 6, 6 would be removed. Suppose I have another element 8 here. 8 does not exist in 8 set A. So we will just leave it like that. So now what is the remaining set that is left off? 1, 3, and 5 would be my A minus B. I hope that is clear. Now let us also check what would be my B minus A. Let us see what do we get when we do B minus A. Okay. Now, what do we mean by B minus A? The elements that are there in B, but they should not be present in A. So that means I have to remove A from B. We have also included 8 here. Okay. So now I have to remove A from B. Check if I have 1 in B. No. If I have 2 in B, yes. That means from B I have to remove A. Next, I have 3. No. Do I have 4 in B? Yes. 4 is also there in A. That means I'm removing the element of set A from B. Next, 5 is not there. 6 is there in A. So it has to be removed from B. Now, what is the only element that is left in B? 8. I hope that is clear. Now, what do we understand from this? We understand that A minus B is not equals to B minus A. I hope this is clear. Now, how do we represent it in the form of Venn diagrams? Let us have a look as to how do we represent A minus B in the form of Venn diagram. Now, you see this. What do we see? A minus B. The B part is being removed. Now B was overlapping with A. So the overlapped part was also removed, right? So this is how we do A minus B. Now let us start the exercise. That is your exercise 1.4. Now here is our exercise 1.4 from the textbook. Let's start this. Let's read the first problem. Find the union of each of the following pair of sets. That means I will have to find what is X union Y. So let us do it. X union Y. What do you think it would be? It should contain the elements of both set X and set Y. So what would that be? 1, comma, I have 1 in both the sets. Next I have 2 in set Y. 2. Then I have 3 in both the sets. 3 and then 5. This would be my X union Y. I think second one can be given as homework. So give it a try. Now, third one. A equals to set of all X such that X is a natural number and X is a multiple of 3. Okay. So X belongs to N and X is a multiple of 3. This is my A. Now, what does B state? X is a natural number and X is less than 6. Now, here it says multiple of 3. Here it says it is less than 6. So, I will have to write the union of these two. Now, what are my natural number? Less than 6. So, what will be the union of A and B? Natural numbers less than 6 would be 1, 2, 3, 4, 5, and x is a multiple of 3. So I will have to write down all the multiples of 3. Now this will be written in my set builder form. So let us write it in set builder form. The set of all x such that x is equals to, what did we get? X is a natural number less than 6. 1, 2, 3, 4, 5. Now, whenever you're doing union, you will use or. Again, what is it? X is a multiple of 3, but we have already written 3 over here. So that means we will have to erase this 3. Now I will write x is a multiple of 3. Is that clear? Why did I remove that 3? Because that 3 is already included here. So this will contain 1, 2, 4 and 5, or x is a multiple of 3. I hope that is clear. Now give it a try to the fourth one. Now moving on to the fifth one. What do we have fifth one? Union of 1, 2 and 3 and my null set. What will be the union of such a set? A union B would be 1, 2 and 3, because null set is a subset of every set. So null set is already present in the set. I will not have to represent it separately. Okay. Now, second question. Let A be equals to A comma B and B is equals to B comma C. Now my question here is A a subset of B? I think we have missed out on the question. There must be something wrong with the question. Yes, B contains elements A comma B comma C. I have written this question wrong. Let me correct it for you. Okay, now that's correct. So now let's continue. What do we have? Is A a subset of B? Yes. All the elements of A are present in my B. So yes, A is a subset of B. Now what is A union B? A union B would be equals to all the elements of A and B. That would be A, B and C. I hope that is clear. Yes. Now, if A and B are two sets such that A is a subset of B, then what would be A union B? Now, look at this example. What did we get? Did we not get the superset as my answer? We have discussed this. Yes. So, the superset would be my answer. That is, my set B would be my answer. Now, moving on to my fourth question. Okay. Now, here, the set A with its elements are given 1, 2, 3, 4. Set B with its element 3, 4, 5, 6. Again, set C 5, 6, 7, 8, 9, 10. Now, what do we have to find? Now, I would be giving 1, 2, and 3 as homework because it is simple. You just have to write down all the elements from it. Now, let us do the fourth one. B union D. Oh my God, D is missing here. So I think I have missed out on the question again. Let me see what exactly the question is. The fourth one, D says C is 5, 6, 7, 8. No, there is some error in the question. C is 5, 6, 7, 8. Let me correct this for you. C contains 5, 6, 7, 8, and D contains 7, 8, 9, 10. I hope this is okay now. Now, I am supposed to find B union D. Now, what would be my B union D? Where is my B? 3, 4, 5, 6. Yes, so I will have to include 3, 4, 5, 6. Now, what does my D contain? My D contains 7, 8, 9, 10. So I will also have to include all the elements from D. So I hope this is clear as to how we have done B union D. Now let us go for A union B union C. That means I will have to write all the elements of A, B and C. So we'll start with 1, 2, 3, 4. 3 and 4 are common. So 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. See here, 1, 2, 3, 4. 3, 4 is common. I'll not repeat. 5, 6, 7, 8. So I hope that's clear. Now let us take 6th and 7th as homework. Let me go for my next bit. Now find the intersection of each pair of sets of question 1 above. Now for the first question that we have done, we have to find the values of intersection here. Now let me quickly erase this for you and let us do this for intersection. Let me just erase the first bit. Okay. Now let us read our first question and see what it is. The first question reads, X is 135, Y is 123. I am supposed to find the intersection. That means I have to only write the elements that are common to both the sets. The only element that is common to both the set that I could see is 1 and 3. Correct? Now again, I think you can take this as homework. Do it as homework. You just have to do A intersection B. Now moving to the third bit. X is a natural number. X is a multiple of 3. So what are the multiples of 3? 3, 6, 9, 12. It goes on. But here it says X is a natural number less than 6. 1, 2, 3, 4, 5. Now I have to do the intersection of these two sets. What do you think? There is only one element that is common. So the answer to this is just 3. I think 4 and 5 can be taken as homework. Now, moving on to the sixth bit. Again, let us do the first problem. A intersection B. Now, what is common in A and B? 3, 5. I don't have 3, 5. 7 and 9. 7, 9 and 11 are common. So, my A intersection B would be 7, 9 and 11. So, I hope you can do these problems wherein you just have to find the common elements. Now, moving on to okay, we'll do the third one. A intersection C intersection D is my third one. A intersection C. What are the elements that are common in A and C? 11. Okay. Now, what are the elements that are common in D? 11 is common in both A and C, but D consists of 15 and 17. So when I do the intersection of A intersection C intersection D, there is no element that is common in all the three sets. So this will be my phi or my null set. I hope that's clear. Now, moving on to your sixth question. Should we go for the sixth question? A intersection B union C. Now, first let's do B union C. What do we get when you do B union C? We get 7, 9, 11, 13, 15. B union C is 7, 9, 11, 13, 15. Now, I have to do the intersection of this with A. That is 3, 5, 7, 9 and 11. So what are the elements that are common in this? 7, 9 and 11. So the answer to this is 7, 9 and 11. I hope that's clear. Now, this is again, eighth one is common to the third one, similar to the third one. So we will not be discussing the eighth one. Now, let's go for the ninth one. A intersection B. Let us write what is A intersection B. What are the elements common in A and B? 7, 9 and 11. 7, 9 and 11 are common in A intersection B. Now I have to do B intersection C. Now what is common in B and C? 11 and 13 are common, right? 11 and 13 are common. Oh, this is union, not intersection. So I'm sorry. Let's do B union C. What would be my B union C? B union C would be 7, 9, 11, 13, and 15. So now I have to do the intersection of these problems. Okay, the intersection of these problems. What is common? 7, 9, and 11. So 7, 9, and 11 would be my answer to this. And I think the 10th one can be done as homework. Now, moving on to the 7th question. Okay, so I think I will do the alternate ones and the rest of one, remaining ones can be taken as homework. I will do 1, 3, and 6. 2, 4, and 5, you can give it a try. So let us try A intersection B. Let's first read the question. If A is equals to the set of X such that X is a natural number, that means it will contains all my numbers. Okay? Set A will contains all my numbers. Now set B is an even natural number. That means it will contains all my even numbers. Set C says odd natural numbers. That means 1, 3, 5, 7, 9 and goes on. Set D is a prime number. So I will only be writing prime numbers here and so on. Now let's find out A intersection B. What is common in A and B? What is common in A and B? I think only I will have to just write 2, 4, 6, 8. All these elements are present in this set. So A intersection B would be B itself, right? It contains all the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It contains only even numbers. So even numbers are already present in my natural numbers. So the answer would be B itself. Okay. Now moving on to A intersection D. This is A, this is D. A contains all natural numbers. D contains only prime numbers. So again, intersection of these two would give me only the list of prime numbers, correct? Now moving on to your sixth question. Okay, C intersection D. Odd natural number. It contains all my odd natural numbers and it contains prime numbers. So I think what is the intersection of these two? It has to be odd prime numbers. That means set of all x such that x is an odd prime number. I hope that's clear. Yes. Now, moving on to my eighth bit. Which of the following sets are disjoint? What are disjoint sets? If their intersections, if the intersection of the two set is a null set, then they are called as disjoint set. So let us have a look. Here, the first bit 1, 2, 3, 4, and it contains natural numbers between 4, 5, and 6. Now, what will the intersection of these two give me? 1, 2, 3, 4, and 4, 5, and 6. It will give me 4. So, this is not a disjoint set as my answer is 4. A, E, I, O, U, intersection C, D, E, F. E is contained in both. So, their intersection is equal to E. That means this is also not a disjoint set. I will get my answer as a null set if it is a disjoint set. Now, x is an even number, intersection x is an odd number. We are trying to find out disjoint set. So I'll have to find out the intersection of both the sets. And if my answer is a null set, which is in this case, what is the intersection? What is common between my even numbers, even integers and odd integers? Nothing. So the answer to this is a null set. So yes, this is a disjoint set. Now, moving on to my ninth question. Now, I think I will only do 2 or 3 problems because we have discussed these. Now, let me go for problems 5, 9, and 12. Okay, C minus A. So, from C, I will have to remove my A. Now, what does A first? Okay, I have 2, 4, and 6. Any of the elements are contained in A? Yes, 6 is contained in A. So I'll have to remove the elements of A from my C. Next, 9, 12, 15. 9, 12, 15. 12 is contained, so I'll have to remove that element from C. Next, 18, 21. Does 18 and 21 exist here? No. So what is remaining now in C? That would be my answer. And that would be 2, 4, 8, 10, 14, 16. This would be 2, 4, 8, 10, 14, and 16. I hope that's clear. Now let's do C minus B. Now again, I have to remove B from C. So whatever elements of B are there in this, I'll just have to remove them. The elements of B are 4, 8. First, let's say take 4 and 8. Yes, they are 8 there. So remove. 12, 16. Yes, they are there. Remove. 20. 20 does not exist. So what are the remaining elements now? The remaining elements are, we are doing our ninth one, right? Yes, C minus B are 2, 10, and 14. Oh, till 6. So this would be 2, 6, 10, and 14. I hope that's clear. Now, let's move on to the last question. That is my 12th question. Now, D minus C. Now, from D, I have to remove my C. Now, this is my D. Now, whatever elements of C are present in D, let us remove them. 2, 4, 6 is present, not present. 8 and 10, yes, 10 is present, so remove 10. 12, 14, 16 are present, not present. So what is remaining in D now? 5, 15, and 20 is remaining. So this is the answer, 5, 15, and 20. I hope that's clear. Now, again, I will do second and third. First one will be given as homework. Y minus x. Now from y, I will have to remove the elements of x. What does x contains? A, B, C, D. Do I have A, B, C, D? Yes, I have B and D. So whatever is remaining, F and G are remaining. So this will be my answer to y minus x. I will just have to remove the elements of x from y. Now x intersection y. Now, intersection, I'll have to find common elements. What are the common elements? A, B, C, D, F, B, D, G. So what are my common elements? B and D are common. So my answer to this is B comma D. I hope that's clear. Now, 11th one. If R is a set of real numbers and Q is a set of rational numbers, then what is R minus Q? Now, I have discussed this when we were talking about our universal set. So please go through that video or maybe little before that and you have answer to this question there. I want you all to give it a try. If you're not able to do it, please leave some comments or leave it in the comment box. We will discuss it. Now, 12th one. State whether each of the following statements is true or false. Justify your answer. Now, 2, 3, 4, 5, and 3 and 6 are disjoint sets. What do you mean by disjoint sets? Their intersection should give me a null set. No, there is something common. So the answer is 3. It is not a null set, so this is not a disjoint set. Why is it not an? What is the answer? How do I justify my answer? As the intersection of these two sets is 3 and not a null set, hence it is not a disjoint set. Now I think you can do second and third. Let me go for fourth one. 2, 6, 10 and 3, 7, 11 are disjoint set. If I do their intersection, what do I get? There is nothing common. So that means this is a null set. So answer is yes, they are disjoint set as their intersection is a null set. Now, all right, that's all for today. I hope you found the lecture understandable. If you have any questions or doubts, please feel free to comment us below or do email us. Also, we would be starting batches of classes for grade 11 and 12 every alternate week. So in case you wish to join us, then do please leave comments below. That's all. Bye bye.